Hello friends, today we will explore in-cab signaling system, a major technological leap in railway safety and control. Traditional lateral or trackside signaling has several limitations, especially when train speeds and traffic density increase. To overcome these challenges, railways worldwide has moved towards in-cab system that provide real-time accurate information directly to the train driver. In this section, we will understand why lateral signaling alone is no longer sufficient and how automatic train protection or ATP forms the backbone of modern in-cab signaling. Problems with lateral signaling. Lateral signaling has served railways for over a century, but it suffers from a number of operational and safety issues. First, poor visibility during fog, rain, snow, or darkness can cause the driver to misread or completely miss a signal. Second, running a red signal, whether due to distraction, missed visibility, or braking issues, poses a major risk of collision. Third, complexity of information. As train speeds rise, interpreting multiple aspects from trackside signals becomes more difficult. Finally, excessive speed can cause what we call the tunnel effect, where the driver sees the signal too late. Overspeeding on curves or turnouts can lead to derailment. With increasing traffic and high-speed orientation, these limitations become even more dangerous. Consequences of lateral signaling issues. The consequences of these limitations are significant. Poor visibility can lead to missed signals, forcing operators to reduce speeds for safety. This results in delays and decreased line capacity. Missing or misinterpreting signals increases the risk of SPAD, signal passed at danger, which is one of the most critical risks in railway safety. Complex signaling can cause driver overload, especially in busy or high-speed corridors. All these issues become more severe as speeds increase and rail traffic becomes denser. This is why modern railways require better safety solutions. In-cab signaling systems. In-cab signaling addresses these limitations by bringing the information directly inside the driver's cab. Instead of relying solely on trackside signals, the driver receives clear, detailed real-time information on a display. These systems follow the same principles as lateral signaling, but greatly improve clarity, accuracy, and visibility. More importantly, the data is also processed by onboard safety equipment, which continuously monitors speed, signal aspects, and braking conditions. Role of ATP, automatic train protection. ATP, automatic train protection, is the heart of modern in-cab signaling. Its main job is to supervise the train's safe operation. If the driver fails to acknowledge a warning or violates a safety condition, the ATP system will automatically intervene and apply the brakes. Initially, ATP systems were designed only to prevent SPAD, signal passed at danger. But as technology evolved, ATP began handling speed control, braking curves, and monitoring safe train operation at all times. Types of in-cab signaling systems. In-cab signaling systems around the world fall into three categories. Point systems. These systems transmit information at fixed points on the track, typically using balances or beacons. They are the earliest systems and mainly prevent signal violations. Point systems with continuous monitoring. Here, information is still received at fixed points, but the system monitors compliance continuously until the next point. This greatly enhances safety. Continuous systems. These are the most advanced systems. They continuously transmit information between track and train, allowing real-time speed supervision, braking curve calculations, and movement authority updates. Examples include ETCS Level 2 and 3. Evolution toward continuous systems. The journey from basic point type ATP to today's advanced continuous systems was driven by increasing speeds and safety requirements. First generation ATP systems only prevent red signal violations. Later systems added warning for caution signals and speed restrictions. Eventually, railways needed systems that continuously monitored train speed and ensured gradual braking before curves and speed restricted areas or stop signals. This led to the development of continuous ATP systems that compute and enforce braking curves, making high-speed operation safe and reliable. Early ATP systems. To conclude, the earliest ATP systems were simple point-type mechanisms placed at fixed positions along the track. They ensured that a train would pass a red signal by providing a warning and applying the emergency brake if the driver failed to respond. Although basic, these systems laid the foundation for modern in-cab signaling and high-speed train control systems. With the constant push for higher speeds and better safety, these point systems evolved into the sophisticated continuous monitoring systems we use today. Okay, thank you.